Guys, in this video we're going to be learning about the empirical and molecular formula. To start, empirical formulas are the most basic form of molecular formulas for a substance. They're the smallest ratio you can have between elements. With that, we know that all empirical formulas are molecular formulas, but not all molecular formulas are empirical formulas. So now let's try some problems with finding these formulas. So let's try this one first. So a compound was analyzed and found to contain 9.8 grams of nitrogen, 0.70 grams of hydrogen, and 33.9 grams of oxygen. What is the empirical formula of the compound? So the first thing we need to do is we need to make sure that all of our measurements that we start off with are in grams. So luckily enough for us, all the measurements of nitrogen, hydrogen, and oxygen in this problem already start off in grams. But if they don't, like if say for example if they start off in kilograms, you need to convert them to grams. But since they start off in grams, we are good to go. So now for all of these, we need to do some conversions from grams to moles. So I've done that here for us. So we do, for nitrogen, hydrogen, and oxygen, we convert all of them to moles. And we do this by taking the molar mass of all of them from off of the periodic table, and we do the mole conversion. So let's do nitrogen together. So we take the 9.8 grams of nitrogen and we multiply it by 1 mole of nitrogen over 14.00 grams of nitrogen, which we get right off of the periodic table because it's the molar mass of it. And then with that, we do the conversion out and we get 0.70 moles of nitrogen. And so if you find the moles for each element, you get 0.0 moles of nitrogen, 0.0 moles of, this should say hydrogen, let me fix that, and then 2.1 moles of oxygen. And then we can move on to the next step. So first step is everything needs to be in grams, and then we do the grams to moles conversion. So now we have everything in moles. We can take our moles and use those to put them with the elements they align with. And so we take nitrogen and we use them as the subscript. So there's 0.7 nitrogen, 0.7 hydrogen, and 2.1 oxygen. And usually when we write formulas, they're whole numbers. So in order to get them into whole numbers, we want to divide these subscripts by the smallest mole that we have to create a ratio. And in our problem here, the smallest number we have is 0.7. So we divide by 0.7 all the way for each of them. And then that gets this goes to 1, this goes to 1, and this goes to 3. So then our new formula is NHO3. And that is our empirical formula, which can also be written as HNO3. So let's try another one. Okay, so this one is asking us to find both the empirical and molecular formulas. So there's another step involved. So we have a compound composed of hydrogen and oxygen and is found to contain 0.9 grams of hydrogen and 0.4 grams of oxygen. And the molar mass of the compound is 34.0 grams per mole. Find the empirical and molecular formulas. So like we did before, we want to do our grams to moles conversion and make sure we start off in grams in order to do the conversion to moles. And we use the molar masses from the periodic table in order to do the conversion. So we get 0.59 moles of hydrogen and 0.5 moles of oxygen. So then we set up that we have 0.59 oxygens and 0.59 hydrogens, and then we divide by 0.59 on each subscript, and then we figure out that we have our empirical formula is HO. And then in order to find our molecular formula, it's the molar mass divided by the mass of the empirical formula. So we know our molar mass, they told us in the problem, was 34 grams per mole. And the empirical formula mass, well, we know hydrogen has a molar mass of 1 gram and oxygen has a molar mass of 16 grams. So that gets us 17 grams. So if we do the molar mass of 34 divided by 17 grams, we get 2 moles. And we can take the 2 moles and then multiply the 2 by our empirical formula to then get H2O2 to be our molecular formula. So I hope this video helped you understand the empirical and molecular formulas. Remember that all empirical formulas are molecular formulas, but not all molecular formulas are empirical formulas. And be careful with your units with grams and moles.